This is one of the problems that we did in the SI session, and I'll show you guys how to solve it. So we're going to balance this redox reaction in acidic solution. So the first step is to assign oxidation numbers to everything that you have. So 1, 2, 3, 4, we're going to assign oxidation numbers to each of these. So because sulfur is in a solid state and its elemental state is just sulfur, it's going to have an oxidation of 0. We know that oxygen it's one of our reference atoms, so it has an oxidation of -2, and hydrogen has a +1 oxidation number. So we use this to find the oxidation of N. We know this whole thing is neutral, so if we wanted to find N, we could set up sort of an algebraic expression if you want to do it that way, or you could see that this is -6 and you have +1. I'll just do 1, and we have our x value. So x would be N. So if we set this equal to 0, because this is a neutral molecule, we bring the N over, or we bring the 6 over, that'll be +6 minus 1. So x would be equal to 5. So the oxidation on N is +5. We can do the same thing with this. Our reference number is -2 for oxygen. So oxygen generally it's in the state of -2. And this is going to be +1. So if we do the same thing here, 2 and 1, that would give us 2 plus x. We don't know what x is because we're trying to find the oxidation of sulfur, and -6 because -2 times 3. And this whole thing is neutral, so it's going to be equal to 0. So when we bring the 6 over, we have 6 on this side, -2, and that gives us 4. So the oxidation number on this sulfur is +4. Over here we have oxygen, again, -2, that's our reference, and we have nitrogen, but we have 2 nitrogens. So we can kind of solve this like 2x minus 2 equals 0 because this is a neutral molecule. So x would be equal to +1. So just a reminder, you don't have to find the missing number the way I'm doing it here. This is just a way to show it for people who don't really understand what's going on. So now your next step is to split up both of your reactants and products into half cell reactions. So I'm going to do the sulfur reaction first. So I take S solid and yields H2SO3. All right. So now I'm going to balance everything other than oxygen and hydrogen. So the sulfurs are already balanced as 1 and 1. We don't have to worry about that. Now I'm going to balance all the oxygens. Because we have 3 oxygens on the right side, I'm going to balance the oxygens on the left side by adding 3 waters. So 3 H2O on the left side. And now that I've balanced the oxygens, now we balance the hydrogens. So we have 6 hydrogens on this side, 2 on this side. So we're going to balance the hydrogens by adding 4 H plus on this side. So now we have 6 hydrogens on this side and 6 on this side. All right. So we've balanced everything. We've balanced the oxygens, the hydrogens. So now we're going to deal with our electrons. So remember, we have 0, this has a 0 oxidation state on this sulfur solid. That's 0. And over here we go to +4. So that means we lose 4 electrons. Electrons are negative. So if this is 0 and it goes to +4, that means we need to add +4 electrons on this side. Because if we went in the opposite direction, a +4 minus 4, because electrons are negative, would give us 0. So that's how we do that. Okay? So we're done with that one for now. So we can move to the next. So HNO3 gas yields N2O gas. And this is actually not a gas, it's aqueous. There we go. So that's aqueous. All right. So now we're going to balance everything other than oxygen and hydrogen. Same rule. So there's 2 nitrogens on this side, and we're going to do 2 nitrogens on the left side. Okay. So now we're going to balance all the oxygens. That's the second part of the rule. There's 6 oxygens on this side because we have 3 here, but there's 2. There's 2 of these molecules, so there's 6 oxygens total on the left side. and on this side we'd have 1. So we're going to do plus 5 H2O. Why are we doing 5 waters? We always balance the oxygens by adding water to whichever side we need to add it to get the same number of oxygens on each side. So now on this side we have 6 oxygens, and on this side we have 6 oxygens, because 5 oxygens and then that 1 there gives us 6 on this side. So now we're going to balance our hydrogens. On this side we have 10 hydrogens, this side we have 2. So, and the 10 came from 5 times 2. So now we can add 8 H pluses to this side. 8 H plus hydrogens to this side. So now we have 10 hydrogens and 10 hydrogens. So now we need to balance our electrons for this one. So the oxidation state on this end from HNO3 is plus 5, and we know that because we did that work at the beginning. And this nitrogen is going to have an oxidation state of plus 1. So there's a change of 4 electrons going from this nitrogen to this nitrogen. So for each nitrogen atom, it takes 4 electrons to go from here to here. But because there are 2 nitrogen atoms, that means we need to multiply that 4 by 2. So to go from one nitrogen atom to another nitrogen atom, it's 4 electrons, but there's 2 over here, so it's 8 electrons. So we're going to add 8 electrons to this side, because remember, if this is plus 5 and we do minus, I guess, 4, we'd get plus 1, but we have to double that, so it's 8 electrons. So now we are almost done. We have to get the same number of electrons on each side. So we have 8 electrons in this half cell equation, but we only have 4 on this one. So everything in this equation we have to multiply by 2, because we need the same number of electrons on each side. So when we multiply that top one by 2, I'm going to write it down here. We're going to get 6 H2O plus 2S yields 2 H2 SO3 plus 8H plus 8 electrons. Okay? So all I did was multiply everything in this one by 2. So now I'm just going to bring down this one, just write this under here, and then we're going to add them together. So I'm just writing down the second half cell reaction down here, just so it can stay a little organized. Plus 8 electrons yields N2O gas plus 5H2O liquid. All right, so now I'm going to add everything on the reactant side together on one side, and then I'm going to add all the products on the other side. So we're going to end up with 6 H2O liquid plus 2S solid plus 8H plus 2HNO3 plus 8 electrons yields, let's see if I can get this better angle. Yep. So 2H2SO3 plus 8H plus 8 electrons plus N2O gas plus 5H2O. So this is a really long thing. So all I did was take all of these on the left side of these two half cell reactions, and I put them on the left side here because they're still reactants. And I took all the products and put them on the product side. So we just added these two half cell reactions. So now we need to simplify. So we could start with a few things here. Your hydrogens are going to cancel out because there's 8 hydrogens on each side, and we'll talk about that in a sec, why they're canceling out. And there's 8 electrons on each side, so we're going to cancel those out. So now, what else do we have? We have 6 waters on this side and 5 waters on this side. So to simplify that, we're going to take away these 5 waters, and we're going to take 5 away from this side, and we're going to be left with 1 water on this side. So our final reaction is going to be water plus 2S solid plus 2HNO3 yields 2H2SO3 plus N2O gas. So this is going to be our final reaction. So some of you may be wondering, we crossed out all of the H pluses and this is an acidic solution. Well, this is one of those rare cases where we don't get H plus in our final equation for an acidic solution. But if you notice, H2SO3 is an acid. So it's still an acidic solution, and acid is being produced in the real reaction, the whole thing. So it's still an acidic solution. So you don't have to worry about that.